Hello, in this lesson, we're going to talk about solving trig equations again. Previously, we talked about solving simple trig equations, right? So over there, we talk about the different methods, the algebraic method, the function method, the graphs, and so on and so forth. And here, we're going to talk about solving trig equations with a little bit more complexities. So let's get started. Of course, we're still dealing with if statements, right? It's just the functions as trig functions is a little bit more complicated. It's a little bit more complicated. So let's start with an example. Example number 1, which I picked this up from the homework. Okay, it says solve for x. Solve for x. Okay, and the example we have here is this one. Okay, we got a cosine x plus 1 equals to 0. Okay, so how do we solve it? How do we solve it, right? Well, we can solve it as a function, right? So if cosine x plus 1, so if we consider this as a rule, right? So the first method, right? The first method is that we view this function as a rule. So this is the rule of the function, and this function is f of x. Right, and we like to find the x-intercepts. That's what we're looking for, right? Because to f of x equals 0, then we're looking for the x, right? So we know the output. So for this function, we're looking for input such that when the rule is applied to the input, it produces output, and the output is 0, right? So that's the scenario. That's a scenario. So one of the method is that just we can look at from the graph. We can look at it from the graph, right? So this function has a graph. And where does it touch 0, right? 1 is equal to 0. So we graphed it. We have proper, setup. And here we go. We got this function, and this function, it touches 0, right? So it looks like we have all these spots. We have many spots as a 0. It's a little bit difficult to identify the points, right? It's a little bit difficult to identify the points. Obviously, it is not exactly 3. So algebraic method will be called for. And obviously, we have many solutions. We have many solutions. If we extend, right? If we extend the picture to see more of it, you can see there are many points, right? So we know there are many solutions, and to find the solution, of course, we like to, using algebraic method. So this method, the function method with the graph, we can tell there are infinite many solutions. Okay, there are infinite many solutions. It's a little bit hard to identify, therefore, we're going to resort to method 2, which is the algebraic method. And of course, if the function equals to 0, right? If the function equal to 0, so we can remove that, right? Then we subtract 1 on both sides, so we get a cosine x equals to -1. And there we go. Then we start to see, where do we find those values, right? Such that a cosine of those angles equals to -1. The domain of cosine is all real numbers, right? So now we start to compare the picture. Or if you like, right? We can find the unit circle. Let me find the unit circle. I'm sure we have the unit. I have the unit circle somewhere. right? Where's my unit circle? I know we have the unit circle somewhere. Just give me a second. Okay, I'm gonna find those unit circle that we are familiar with. Oh, there we go. Okay, so we found the unit circle, right? So the second method, we can also combine looking at the unit circle, right? When we look at the unit circle, it's even more obvious, right? It's even more obvious. Well, you look at the red number. When would the red number equals to -1? Do we see it? It's right there, right? We see it. The terminal is here, right? The terminal is pi. So negative pi, positive pi, negative pi, right? Positive pi, negative pi. And then for this terminal, and this is only one terminal, that gives us a cosine of that angle equals to -1. And that's the one and only. But that could be the terminal for many, many angles, right? So pi, 3 pi, 5 pi, and 7 pi, right? And negative pi, -3 pi, -5 pi, and so on and so forth, right? So now can we identify these points? Yes. So this point probably is pi, 3 pi, 5 pi, right? Negative pi, -3 pi, -5 pi. Okay, if that makes sense to you. Let me mark it. Okay, let me mark it. So here, so look at this point. This point is going to be what? It's going to be pi, comma 0, right? And this point is going to be 3 pi, comma 0, right? And over here is going to be 5 pi, comma 0. On the other side, this is going to be negative pi, comma 0, and -3 pi, -3 pi, comma 0, and so on and so forth, right? And this one, that's going to be -5 pi, comma 0. So we found the solutions. How do we express these solutions? So from the curve combined with observing the unit circle, right? So we recognize that, and that's the only terminal, right? So that's DRA, right? So from the definition, we found the angle. The angles are plus pi, minus pi. So the x must be positive, negative, multiples of pi, but not even number multiples of pi, okay? So it's a odd number multiples of pi. So those are the solutions. Okay? And of course, on the curve, those are the x-intercepts. Okay? So that's it. Okay, DRA. Okay. And let's look at another ones, right? You can see to solve this equation, to solve this if statement, we transform it into a simple trig equations. So let's look at another one. Example number 2. And this one, of course, is also in the homework. Okay. It's root 2x, root 2 times sine x plus 1 equals to 0. We can use the function method, all right? We can use the function method, all right? But most of the time, we'll just use the algebraic method to simplify it. Okay, so what do we have? We're going to subtract 1 on both sides. So √2 times sine x equals to -1. And sine x will be equals to -1 over √2. Okay, and rationalize it. So we get a -√2 over 2. -√2 over 2, sorry. Okay, -√2 over 2. And how do we solve this simple equation, simple trig equation, right? We can use unit circle, or we can use the graph, right? We're very familiar with sine curve. So let's mention this method, right? The method 1, the function method. Okay, the function method. So we're very familiar with the sine curve. And then what do we have? We have sine x. We're going to graph it, right? Horizontal line. We're going to draw a horizontal line. Y equals to -√2 over 2. Right, I'm going to draw a red line. It crosses. So we have all these cuts, right? We have all these horizontal cuts. How many solutions do we expect? How many solutions do we expect? A lot, right? We have lots of solutions. So now, lots of solutions. So what are they? How to identify them? How do we identify them? It looks like it's a little bit difficult to identify from this graph, right? If you draw these pictures on decimals, you probably could identify this. But, you know, it's just so much easier to identify the points on the, you know, on the by the horizontal, by the graph to identify the points precisely. So using the unit circle is going to be very, very helpful. It's going to be very, very helpful. So we look at the unit circle, and since we're given sine of x equals to -√2 over 2, right? With that condition, we're going to look for the blue numbers. Which one give us the blue -√2 over 2? Do we see them? Yes, we do, right? We see them. We see one here, the fourth quadrant, and we see one over here in the third quadrant. We don't see anything else, anywhere else, just these two terminals. So with these two terminals, you can see we have DRA, right? We have D. So from the definition, right? From D, right? We get to find the R, which are the reference, which is the reference angles. And now we're going to determine what? We're going to determine the A. Okay, so from D, from definition to R to A, DRA. So now we have just identified these two terminals, right? These two terminals. One terminal is here. Maybe I should not be using the red. Okay, using the green. Okay, so one terminal is here, the other terminal is over here. Right, so we identified from definition the reference angles, and then we're going to find the A. Right, we're going to find the A. How do we find the A? Well, the angles are all measured from the standard position, right? So you can measure from counterclockwise or clockwise, but you have to get to these terminals, right? You get to these terminals. So if you get over here, if we do counterclockwise, the angles would be what? The angles would be x equals to 5 pi over 4 And there are many, many angles terminate here, right? And then we plus 2k pi, plus 2k pi, right? And there's another terminal, or how about this other one? That's gonna be 7 pi over 4 plus 2k pi, plus 2k pi, that's it. Can you express these angles with, you know, clockwise angles? Of course you can. Of course you can. Okay. So now we found the solutions. We found the solutions. How do we express it? You can express it just like this. That'll be good, right? Of course, you have to tell the reader what k is. K are integers. Integer. Okay, any integer. The other way to express it, is as follows, okay, which is very typical. The other way to express it is you write it as x equals to, you're gonna put some, you write it in this specific format, okay, and 1 column, 2 rows. Okay, so what you do is that you put these two forms on the table. So these are, it's also OR relationship. Okay, so either this way to express your answer or this way to express your answer. Either way is fine. Okay. Okay, either way is fine. So you can see that in this process, right, we use graph method, algebraic method just to identify the answer properly, correctly. Okay. Let's see. Let's look at another one. Okay. All these angles we've been seeing, they are special angles. Okay. Maybe we get to see some non-special angles, right? Maybe get to see some non-special angles. This one, example number, this would be number 3, right? Yeah. Wait, example number 3. Okay, so this one says solve for x. Excuse me. Solve for x, where we have 5 times sine x minus 1 equals to 0. Okay, there we go. How do we solve this one? Well, we can algebraically, to identify, you know, to make it a simpler function. So that's sine x equals to 1/5, right? Subtracting, well, adding 1 on both sides, divide both sides by 5. So this is a simple trig equation. A simple trig equation. Once we get this simple trig equation, we can use the previous method to solve it. But the question here is that it is not a special angle. It is not a special angle. Do we have a solution? We certainly do, right? If we take the picture, right? If we take the picture like this, and we draw a horizontal line 1/5, right? Instead of, what do we have now? 1/5. And there we go. We have many, many solutions. The question is, how do we express those solutions, right? How do we express those solutions? So that's how we're going to use our, do we use unit circle? You could use a unit circle. Okay, if we use unit circle, so here's a narrative. Okay, if you use unit circle and here's a narrative, and the blue number is 1/5. Okay, the blue number is 1/5. Okay, so the blue number 1/2, √2/2, √3/2, 1/5 is going to be somewhere like that. Okay, so this will be the terminal, and positive 1/5. Okay, and there will be another one in this terminates in the second quadrant. there's another 1/5. So what I meant here is that on these two terminals, okay, on these two terminals, there's a blue number. Okay, there's a blue number. Okay, we're not going to worry about the red number. Okay, the blue number here is going to be 1/5. Okay, and there's a 1 over here, this point. There's also, we don't know about the red number, we can find out, and the blue number is 1/5. The question is, how do we represent this angle? We call it theta. How do we represent that angle? Okay, we don't need the red number, so I'm not marking it. Okay, you can find it. How do we represent this angle? This is the time we get to use arc sine. Okay, this is the time we get to use arc sine. Okay, so how do we use the arc sine? So theta equals to arc sine of 1/5. Okay, so this theta will be arc sine 1/5. Okay, the range of arc sine is between -pi/2 to +pi/2. So this angle is perfectly represented. How about this other angle? This other angle, right? How do you measure the other angle? Well, this is how you measure the other angle. You can measure counterclockwise or clockwise. You terminate here. If you measure this way, what will be this angle? This angle will be pi minus theta. This angle will be pi minus theta. So here we go. We found these two terminals. So what will be the solution? What will be the solution? The solution will be x equals to theta plus 2k pi, or x equals to pi minus theta plus 2k pi. Okay, where k is the integer. Okay. See, non-special situation, you can see the necessity of using arc sine. Okay, you can see the necessity of using arc sine. If you introduce arc sine for 1/5, you get that theta you needed. Okay, so that theta will be considered known. And we know that theta is between -pi/2 to pi/2 in particular, because 1/5 is a positive ratio. Therefore, theta is between 0 to pi/2. Okay. Now, so let's put the answers together. Okay, let's put the answers together. Okay, let's put the answers together. And what I can do is that I'm going to draw you another rectangular system. Okay, so we already have the answer, but I'm going to draw these rectangular system one more time, which is a more general form of drawing this. Okay, so y equals to 0. We're going to draw this rectangular system. I'm going to draw this rectangular system. Meanwhile, I hope you guys see this whole process all over again. Okay, we have a, 1/5, right? So we're going to mark those properly. I'm going to mark those properly. Okay, so there's a blue number, there's a red number, right? 1/5, 1/5. And for that 1/5, right, is the, because we know that sine x equals to 1/5. Remember, sine x equals to 1/5, that's y over r, right? That's y over r. Y over r. So r is 5, y is 1, right? So I can put that terminal in place, right? If y is 1, r is 5, then I'm going to put the point in place. Okay. We need to find the x, right? We need to find the x in order to mark this properly. Okay, so that's not difficult to make. So I'm going to draw the picture to show you the whole picture, the whole process, right? So that's 5. That's 5. Okay, so this is 5. And this is 1. Okay, so this is 1. This is 1, right? So what will be the red? What will be the red? The red, oh, the R relation, the R should be the wrong. Let me use a different color for R. Okay, I'm going to use a green for R. So R is 1, and this is 1, this is 5, right? So 1 over 5. We need to find the red. We don't really need it, but just for the sake of practicing it, the red should equals to what? The red piece should equals to Pythagorean theorem, right? So that's going to be 5 squared minus 1 squared, right? And that equals to root 24. Root 24, 24 is 4 times 6, so it's 2 times root 6. Okay, so I'm doing this so that we can express this point. We can express this point. So this point, okay, so let me put this point in place. This point, okay, has a red number and blue number. The red number is 2 times root 6. The blue number is 1. Of course, this is not on unit circle. This is on circle radius 5, right? But if you put it on unit circle, what will happen? You divide this by 5, you divide the other by 5, right? You divide this by 5. So if you want it to be on unit circle, you divide 1 by 5. Remember the 1/5 we showed earlier? Okay, this is 2 times root 6. So now I'm gonna take you to get there. Okay, we put a unit circle right here as a comparative study. Put a unit circle right next to it. Okay, so not on the unit circle. Right? So we have this is the 5, right? And that's the 1. This is the 1. And this is the red. Okay. The red is 2 times root 6. Okay, so the red is, so this point is 2 times root 6, comma, and the blue is 1. Okay, back to the unit circle, right? We did earlier, 1/5, right? 1/5. So this point, okay, I'm gonna mark it over here. This point, okay, I'm gonna put a little heart here, right? So that point has a red number and blue number. The blue number is 1/5. Okay, that 1 divided by 5. And this number 2 times √6, right? So that's a red number. That's gonna be 2/5. We also divided by 5 times √6. Okay, so that's on unit circle, that's not on unit circle. Do you guys see that? Okay, so now if I mark that point, on the unit circle, that's 2 times √6, comma 1, okay, and that's the dot there. Okay, my drawing is not that perfect, right? Because I didn't have precise scales, right? So now this point, this red dot is 2 times √6, 1. If I draw even better, okay, I would draw the blue. So this will be, let's draw the red first. Okay, let's draw the red first. The red, right? And the blue. That's the blue. That's the blue, right? And last but not least, that should do the work. There, right? So this is the 5, this is the 1, this is 2 times √6, okay? And this point is accordingly, but it's on the unit circle. It's on the unit circle. I cannot apply the software to this picture here, but you can see that, you know, that's the red, the blue, and here the red, the blue on unit circle, right? But anyway, I hope that helps you to review. So now we represent this theta. This angle is theta. So that's theta arc sine 1/5. But there's another terminal on the other side, right? So we're going to draw the other one. Okay, we're going to draw the other one. So we're going to draw this other one. Okay. Right there, right? So there's another terminal on the other side. And there's another red. There's another red. And there's another blue. There's another blue. That should do it. Right, red, blue. And finally, the green. That terminal. That terminal. There we go. Okay, so these two terminals. This angle is theta, and the other angle is pi minus theta. Okay, so this angle is theta. Okay, so this is theta. And this other one, this other angle is pi minus theta. Okay, so this is how much it takes to draw a picture. In the future, you might need to do this for other reasons, okay, for other purposes. But that's how you, let's see how you do from DRA. That's how you do it from DRA, right? But anyway, so I'm gonna put this as red, the red line, right, the red line. But anyway, so how do we show work? How do we show work? Okay, you understand this much, right, from DRA. And how do we show work? Solve for, right? So let's see how we show work. We got that part. Then you can say let theta equals to that, right? And next, you may like to write this way. Okay, I like it. I like to write it this way. X equals to, with this, I put this one over here. This piece over here. And K, I'm gonna put it right here. Okay, that's it. Okay. And how much, that's how much work you need to show would be better if you have this picture, You can use a unit circle, it just make sure you mark it properly. You can mark it properly, okay? All right, so that's example number 3, okay? So let's look at another example. This one is gonna be like this. Example number 4, okay? I take a homework question, right? So it's 4 times cosine squared minus 3 equals to 0. Okay, so just solve for x. Solve for x. Okay, solve for x. How do we solve this? Right, how do we solve this? You can treat it as function. Whoops, I missed the x. We treat it as a function, but we like to do some algebraic manipulation. Okay, we like to do some algebraic manipulation here. So we're gonna add 3 on both sides. So we got 4 times cosine squared equals to 3. Divide both sides by 4. So cosine squared x equals to 3 over 4. And let's see what we can do here, right? We can take square root on both sides, right? We can take square root on both sides. So taking square root, the square root of 3 over 4 equals to root 3 over 2. It looks like we're getting some special angles here. On the left-hand side, it's absolute value. It's absolute value of cosine x equals to root 3 over 2. And this obviously is a bit more complicated. And now cosine x will be equals to plus or minus root 3 over 2. Recall that the model for absolute value, right? The model for absolute value where we have omega equals to, say, root 3 over 2, right? So that solution would be omega equals to plus minus root 3 over 2, right? So that's our model. So we basically have from one equation, one big if statement, we get 2 big if statements. One is a cosine equals to negative root 3 over 3, and the other one is one is negative, the other one is positive. So we're going to solve 2 equations. 2 equations. 2 equations means what? Let's look at this, right? This is an OR relationship, right? If you draw the cosine curve, we are pretty familiar with the cosine curve, don't we? Okay, we're pretty familiar with the cosine curve. And if I'm drawing this curve like this, and you want to see how many solutions do we expect, and we're actually going to draw one horizontal line, two horizontal lines to see where they cross, right? So we're going to draw two horizontal lines. Okay, there's one here, right? I'll make it red. Another one. There, two horizontal lines. You can see we have many solutions, don't we? We have many, many solutions. So let's see where the crossing. There's so many crossings. There's so many crossings. Looks like there's some kind of symmetry, isn't it? There's some kind of symmetry in here. Do you guys see the symmetry? Positive, negative, positive, negative, positive, negative, right? There are all these symmetry. We have lots of solutions. How do we identify these solutions? Well, we need to resort to algebraic means to identify the solutions, right? So this horizontal line is y equals to √3/2. And this other one is negative √3/2, right? So we have lots of solutions. So now let's move forward. Look at the unit circle. Look at the unit circle. When we look at the unit circle, we need to look at, this is interesting. Look at this, okay? Cosine equals to √3/2 or negative √3/2. So how many terminals do we have there? How many terminals do we have there? Let's identify the red √3/2. Red √3/2, right? So let's identify those numbers. Red √3/2, negative √3/2, negative √3/2, positive √3/2. And we got to identify 4 terminals. Look at that. Look at those. And the solution is going to be found very quickly, right? It looks like this is a straight line. This is a straight line. And this is another straight line. In other words, if you identify one, you just add a pi, you add a k pi, you get the other, right? You get a k pi, you get the other. So we're very close to it. We're very close to it. So let me move these things elsewhere. Sorry. Okay. There, we're back. Okay. So what are those solutions? Well, this angle, it looks like pi/6. So if pi/6 plus k pi, we get all of those angles on this line. Negative pi/6, we got all the angles, and plus k pi, we get all the other angles. So now the solution, okay, gosh, let me see, I can get it back. Wait. How do I get them back? There. Okay. So we basically have solutions. Our solution is going to be what? Positive, negative pi/6. Plus what? Plus k pi. That's it. K are integers. And that will cover all these 4 terminals. We'll cover all these 4 terminals, right? With special angles, this one is very, very straightforward. Okay, very, very straightforward. Okay, so let's put the answers together. Okay, so solution. So now you can identify this is pi/6, negative pi/6, right? So they are symmetrical. They're symmetrical. This solution, that solution. Well, It's even function, cosine is even function, right? So let me see, let's see how we shall work. The solution would just be what? Already wrote it down. Wait, where did I put it? Where did I put it? Right here. Solution. That's it. That's the solutions. That's the solutions. You can see that the function give us clue as how many. Okay, and the unit circle really help us to find the terminals and make us identify those terminals. So DRA. Okay, DRA. So how to show work? In this case, the amount of work you need to show is really these plus you identify these 4 terminals. These 4 terminals. Okay. And these 4 terminals, and I'm going to use I'm going to draw it. I'm going to draw it for you so it's nicer and cleaner. Okay. So I'm going to draw these terminals for you. And because using unit circle, you have to mark all of that. You don't need to mark any one of those. Just use a rectangular system and it will be more than enough. It will be more than enough. Okay, so I'm going to give you this simple version of marking your terminal. Marking your terminal. Okay, just hold on a second. It won't take too long. Just be patient with me. And at the same time, you can try to do your own because these are special angles, right? So we already know the terminal, right? √3/2, half, right? So √3/2, half. Where's my, okay, √3/2, half. So we got those terminals, right? Wait, oops. √3/2. √3/2 half. Okay, you just need to show these 4 terminals. Terminal 1, terminal 2, terminal 3, terminal 4. So all of these 4 terminals are marked. There you go. Okay, and you can tell the reader that this is a pi/6. This is pi/6. That's all you need to do. Okay, so this is a pi/6. Pi/6. Okay, you can, if you like, you can even mark that this point is √3/2. That's a red number, sorry. That should be a red number. Okay, that's √3/2, right? And you don't have to mark the blue. And this is a negative √3/2. You don't have to mark the blue number. And this one is negative √3/2. You don't have to mark the other one. You can mark this number, which is √3/2. You don't have to mark the blue. Okay, of course, there's these points on the unit circle. You can mark it that way and mark pi/6. That will make it pretty clear. Okay, and this is negative pi/6. So if you mark a picture like this, it's pretty clear. It's pretty clear. Okay, one last thing I can do is that I can put those dots in place because you mark those dots. Right, so I'm going to mark those dots. Make it a red dot. So 1, 2, 3, 4, all 4 dots are marked. All 4 dots are marked. Okay, so that's pretty clear to demonstrate that you understand. Okay, you can mark the blue number half if you want. If you don't have to. If you do, make sure you mark it properly. Okay, if you do, mark it properly, mark it correctly. Okay, 1/2, 1/2, and negative half, and negative half. That's it. That's how you show your work. Okay, that's how you show work. Okay, let's move forward. Let's move forward. Okay, that's example number 4. Let's look at example number 5. Example number 5. Example number 5. I think we should do a tangent. Okay, let's do a tangent. So we got a solve for x, right? We've done sine, cosine. Let's look at a tangent. We get the tangent squared x minus 4 equals to 0. Okay. In these cases, you probably like to do some algebraic manipulation, right? So you have tangent squared equals to 4, right? And then you get tangent taken square root, right? Taken square root. And that's equals to 2. On the left-hand side, it's going to be absolute value of 10 equals to 2. Okay, so we get a situation that 10 is going to be equals to plus minus 2. Okay, not a special angle, not a special angle. What do? We have 2 equations here. So we have 10 of x equals to negative 2, right? And the other one is 10 of x equals to positive 2. There we go, right? One is a positive 2, the other one is negative 2. Well, how to find these ratios? Not special angle, right? Not special angle. What do? Well, this really gives us a definition, right? What is the definition? So on the 2 part, it's really just what? Y over x, y over x. So 2 can be seen as 2 over 1. And what does this tell us? It tells us y equals 2, x equals to 1, right? Y equals to 2, x equals to 1. Okay, I will show you how to show work. So that's for 10 equals 2. So you can draw unit circle. You can draw a rectangular system accordingly. Okay, so now let's identify the terminal, because there's also this negative 2 here, right? For the negative 2, according to y equals to x, and you get negative 2, hold on, 175%. Let me just make sure you can see the negative sign. That's y equals to negative 2, x equals to 1. Okay. And now the situation gets more interesting, right? For this case, right, you have a ratio 2, right? It could also be negative 2 over negative 1, right? So your y can be positive 2 or negative 2. X can be positive 2, negative 2. for this one, it could also be equals to 2 over -1. Okay, if you look at all these possibilities, right? If you look at all these possibilities, in this case, you have that, right? You could also have that, 2 -1, right? Those are cases. And these ratio will make a -2. And these other ratios, you could have cases too. You could have this case. You could also have the other case. Okay, you could have either case. You could have either case. What does that mean? We have 4 cases, right? 4 points in the 4 quadrant, So here we go. We get to find the terminal. We're identifying the terminal, right? Not special angle, no problem. That's how we identify the terminals. Okay, let's identify the terminals. So let me make the adjustment. Let's make the adjustment. Okay, so let's make this and feel free to draw your picture. Feel free to draw your picture accordingly. Okay, each case, right? Say 2, 1. I'm sorry, this is the point are these. Okay, this is 1, 2. And this one is -1, -2. And this case, okay, is 1, -2. And in this case, is -1, 2. So we have all these 4 points. Okay, so it looks like we have all 4 cases. And let's just put the points in place. So we're going to identify the terminal. There. Okay, so we're going to have a red dot. Right, there's another case, which is, this is a negative. Right, and the other case, this is a negative. Another case, negative. So see if we get all 4 points. Yep, we got all these points, right? 1, -2, top, bottom. Yep. So how about these terminals? Right, we got these 4 points, and we connect these points with the terminal, with the origin, we get the terminal, right? So that's 1, and that's another one. That's another one, and that's another one. How many do we have now? 4 terminals. We got 4 terminals. Okay. Once we have these 4 terminals, does it matter it's a unit circle or not? Of course not. And then the thing is, we need to represent the angle. This angle. How do we represent this angle? Well, this angle is in the first quadrant. We can use arctan. So I'm going to call this theta. Okay, I'm going to call this theta. So theta is equal to arctan of 2, positive 2, right? Because this point is 2 over 1, right? 2 over 1. It must be theta. So if we get theta on this terminal with plus k pi, we got this whole line covered. How about this angle? If that's theta, right? If that's theta, and we know that this is negative theta. right? Negative theta, let me rewrite it. If that's theta, this is negative theta. Okay, so theta identified plus k pi, negative theta plus k pi. So our solutions are what? So our solutions are x equals to plus minus theta plus k pi. That's our solutions. That's all of our solutions. Yep, that's all of our solutions. That's it. Okay. Let's see, how do we show work? When you show work, you don't have to show all of these. You don't have to show all of these details. Okay, so let me give you a version of showing work. Okay, and this version of showing work would be like this. Okay, right here. You're going to show work. Okay, that's the question. And you go down that line. You have -2 here. And this one is just 2. And you have that picture. Okay, you bring that picture into, let me make a little adjustment to this picture. There. Okay, so this is the better picture, I think. And you take this picture and you show work along with it. On this picture, if I were you, I would mark this angle as theta. That's it. And that will be sufficient in terms of showing work. Okay. You can mark these points if you wish. Mark these points. Okay. Mark these points as these. So this blue, okay, let me put the points like this. Okay, put the points like these. Okay, and then the red. So this is 1, this is a -1, this is a -1, and this is a 1. Okay, and the blue, so this is the 2, that's 2, -2, -2. So when you show your work on your picture, you mark like this, will be great. Okay, it'll be great. Do you need to draw the red and blue? It would be nice if you do. In fact, I would do it for you just to demonstrate. You don't have to show that much, but I really want to make that connection. Okay. Okay, the red and blue, right? So this is -1, 0, -1, -2. So this should be the blue. Yep. That's the blue. I'm gonna make it thicker. Make it another blue. Get that blue. Yep, we get the blue. And how about the red, right? Let's show the red. Yeah, let me just do this, right? The red thick line. Okay. Whoops. There, the red, blue, they're all expressed properly. If you like, okay, I think this will be complete in the sense that recall the color tone we'll be using, right? Red for X, blue for Y. So tangent is Y over X, right? So making that connection, you can clearly see this is what this is. This is just DRA, right? DRA, so solutions like that. Okay. I think we're gonna have to do another lesson because we have some more more examples to be covered. In those cases, you can see the factoring techniques. The factoring quadratic function technique will be very, very useful, but I'm going to make that another lesson. And thank you for watching. Until next time. Goodbye.